Great. So basically in the last class, we completed this chapter here, how to write a Pascal program. Now, once you've done your SBA, this should be relatively familiar to you. We basically did a summary of all the statements and so on. So if you want to run through of that, you can watch that recording. So today we're going to be starting 10.3, running a program, and we're going to run through it to see what information we have to remember for our exam. So the first paragraph states that usually you will go through several steps before you can even type your program instruction, let alone view output from your program. At this stage, you are ready to see your program run. After you've typed your program using an editor, it is called source code. So this term here is important to remember. I think I also mentioned it. It was also mentioned in this chapter also. What did I say also twice? Yeah, so source code refers to the code that you type into the editor. So let me just find Easy Pascal. So when you have Easy Pascal open or any software that you type your program language into, that is called the source code. So this here is called the source code. If we go and Google examples of Python program, and we look at the image, and I'm looking at this program here. This here is the source code for that program. So basically the instructions for that program that we type in a text editor is what we call the source code. Hope you guys clear on that. So next, it needs to be tested for correctness. To do so, the source code must be translated into machine language called object code so that the CPU can carry out the program instructions. So I sent this image last week. Let me see if I can find it. Where is the image? It is supposed to be this here. So your computer has one, two, three, roughly three stages of languages. We have the machine language, also called machine code, object code. Those terms are used interchangeably. So you have the machine language, the machine code, object code. That is what your computer understands. That is binary, ones and zeros. That's all your computer understands. Then we have the assembly language. We have the high-level language. The previous class, we went into detail about all of these here. The high-level language is basically the programming languages that we use today. Pascal, C++, Python, and so on. So when you type those languages into a text editor, you call that the source code, that high-level language. Now, your computer does not understand that high-level language. It does not understand that source code. So you have to translate that into machine language, also called object code, and the CPU now is going to process those instructions. So with the diagram, everything is basically going downwards. It's all trying to get to machine language. So even though a program might be written in assembly language, it still has to be translated to machine. You write a program in high-level language, it still has to be translated to machine language. Only then will it be able to be processed by your CPU. Everyone clear on that? So from source code to object code, converting a program from source code to object code is performed by a translator program. Sometimes a program listing is shown, which is a printout or a soft copy of the source of program instruction as a reference while working with and coding the program. So this important part here, a translator program converts the source code into object code. These programs that translate a specific program from one language to another, which is high-level language to low-level language, we have, these are the names of the translators. We have interpreters, compilers, and assemblers. These are the three names of the translators that translate high-level language to low-level language. Can I copy this? Yes, I can. Can I paste this in Paint? Yes, I can. Can I make this larger? Yes, I can. So, when you are going from, I think I also sent the image. Why am I doing this? Where is that image? Where is that image? Where is that image? Where is that image? Right, no, not you, not, or did I not send that image? Right, let me see if no, I'm not seeing it. So more likely I didn't send an image like that. So let me try to find one. So I'm looking for interpreter, compiler, assembler. Wait a minute. See. Yes, I know I sent it. I sent this image here also. So when you are compiling, sorry, you're translating your high-level language to machine code, you're using what is called a compiler. When you are translating your assembly language to machine code, you are using a assembler. Now, a interpreter is also used for translating high level to machine code. So both the compiler and the interpreter are used for translating high level language to machine code. Only the assembler is used for translating assembly language to machine code. Where is the image I just downloaded? So here we can see the difference between them. So compiler, software that converts program written in a high-level language to machine language. Interpreter in purple, software that translates high-level language into machine language. So both compiler and interpreter do the same thing, but that's that they work differently. IBM is an assembler, right? IBM is a company. Yeah, IBM is a company. Assembler, like how we have Dell and so on. Yeah, IBM is a company that makes computer parts and so on. Assembler, I think they make software. IBM software. I think they also make software. IBM products. But I think they're more into hardware rather than software. They're more into hardware. Not really. I think, but I'm not seeing IBM into hardware and software products, including computer servers, storage system equipment. Yeah, they're more into hardware, not software. Computers, servers, storage system, networking equipment. Information management system, database service tool. Well, I guess they made some software. So going back to the image, the assembler, software that converts program written in the assembly language to machine. Now, what's the difference between the compiler and the interpreter? The compiler converts the whole high-level language program to machine-level language at a time. So, whereas the interpreter does it line by line. That's the difference between the two. The difference between the two, the wrong color, will that work? Yeah. So this one here is the compiler. This one here is the interpreter. The compiler translate the entire program at once. That was what it does. Translate the entire program at once, whereas the interpreter translates line by line. So going back to Easy Pascal and looking at your program. So what the compiler would do, it would take all of these lines of code, the source code, and translate it everything in one go. Whereas the interpreter is going to go line by line. It's going to take this line, translate it. 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 It goes line by line. So examples of the language. Well, this is not important to remember. C and C++ uses compilers. Ruby, Perl, Python, PHP uses interpreter. And the assembly language uses an assembler. Oh, it's right here. Interpreter translates the source program line by line. And if an error is detected, then translation is aborted. So when it's going through and it finds the error, as it's translating the line, it stops there. If no errors are detected, the interpreter instructs the control unit to execute the translated instruction. This cycle will be repeated for every instruction in the program. This is an easy but inefficient way of executing or running programs not written in machine code. BASIC is a language which is interpreted. So, as I said, interpreter languages, they translate line by line, checking to make sure if everything is working, one line at a time. If any line is wrong, it just stops there. And then you have to go and fix it. And then you run the program again and it goes again like that until it either works completely or it finds another line that is not working. So this is basically a block diagram. You start off here with the source code. The interpreter going to translate. If there's an error, it's going to tell you there's an error. You gotta fix the source code, and you're gonna translate again until everything is okay. Then you see the final result. A compiler translates all program instruction at once. So as I said, it takes everything in one block and translates everything, and produces a standalone object program that can be executed or run on its own. Error checks for syntax and logic errors are performed, and an error summary is issued. Once the program is compiled and no errors are detected, the compiler will then instruct the control unit to start executing the program. If the program produces the incorrect output or stops unexpectedly, then another type of error may be caused. Otherwise, the object program will be executed each time it is run, but the source code only needs to be compiled once. If there are any modification to the source code, then it must be recompiled. COBOL is an example of compiled or compiler. So what they're basically saying there is that when you are working in your program, because this is a compiler program, and notice you have the word literally there at the top, compile. So this is a compiler program. So anytime you make any modification, any changes, anything you're typing, you have to compile first. You are translating it into the machine code. And when you run, it runs that program. It runs that machine code. If you go and make a change, I think this program is a bit more sensitive, so you actually don't need to compile, because it's basically, I think it compiles and then runs. But basically, you must compile, before you run that program. That's basically the conversion process. So, 1, you have the program source code. 2, you compile or you translate. Now, if you have any error, so you start off here, if you have any error, syntax or logic error, you have to go and check back the source code. So you check to see if you type something wrong, if you put the wrong sign and so on, then it compiles again. Now, if everything is okay, you have no error, it's going to compile and translate it into the object code. And in the object code now, that's when you run it, that's when you select run, it's going to run the object code and executes the object code to obtain results, or basically it runs the program. Now, if you get, so this is a good example as to when you get the 3 types of errors, because this could be an exam question. So this is a good diagram as to when you experience errors. So when you are compiling, that is when you're going to get syntax errors and logic errors when you are compiling. When you are running the program, when you run the object code, when you execute the program, that is when you're going to get runtime error. So you got to remember that. And basically you get the working program if you don't get any error. So program errors. Any question from anyone? No questions? All right, let's continue. Programming errors. Often.
Sir?
Yes.
Sorry, I have a question.
Mm-hmm.
The object code, is that just the compiled version of the source code?
Yeah. So the object code is your machine language, basically binary.
Okay, sir.
So your remember the high level language has to be translated So this source code has to be translated into object code. Source code is your high-level language. Object code is your machine language, your binary. The compiler is your translator. That's what's converting it. Any other questions from anyone? Remember, we have three translators: interpreter, compiler, assembler. Interpreter and compiler, that's used to translate the high-level language to the low-level language. Your assembler is what translates the assembly to low-level. It's basically three names: machine code, low-level language, object code. Is it possible to understand a real sheet? Yes, it's possible, but very complicated. Because remember, machine code is basically binary. So once you can memorize the combination of zeros and ones and what it represents, yeah. But obviously, it's going to get confusing when you start seeing a bunch of 0 and 1 and you don't know which one starts from where and ends from where. So that's why we don't code in binary, because it's going to be very complicated. Almost impossible. Whereby that's why we also code in high-level language, because we understand these words. We're clear as to what these words mean. We're more familiar with them. So that's why we write programs in these languages and do a conversion. All right, if no other questions, programming errors. Often, when the computer is compiling or interpreting your source code, an error, whether minor or major, will cause it to either output wrong results or not reach the stage of output at all. There are different types of errors which will cause a program to crash. Your first type of error is your syntax error. Syntax error occur when a mistake is made in the language rule or sentence structure of the programming language. A syntax in programming is basically the rule that you must follow when you're typing a statement, when you're doing anything, when you're typing your programming language. Like for instance, this one line here that I highlighted, the syntax is that you must write right line, open bracket, single quotation mark, close quotation mark, close bracket, semicolon. That is the syntax. That's the rule. If you do anything otherwise, you're going to get a syntax error. If I delete that bracket and I get an error, bracket expected. That is called a syntax error. I did not follow the rule. Examples of syntax errors include misspelling a variable or a keyword. Syntax errors stop the program instruction or source code being converted to machine code. So if you type anything wrong, it will not be converted to the machine code. Tools used with the program usually detect syntax errors quite easily. Are we clear on that one?
Yes, sir.
All right. So this example of syntax error if age. So here, incorrect syntax such as operator is missing because we can't say age for the two. What about age? Is it equal to? Is it more than? Is it less than? The system won't know. So that there is an error. We didn't spell begin here correctly. So that there is another example of a syntax error. Now, what is a logic error? Logic errors occur when a programmer makes mistakes in the sequence of the program sentences. Now, such as using the wrong mathematical formula, wrong operator, incorrect use of looping structure. The program will usually compile That is, the compiler will be able to convert. Compilation with logic error does not generate any syntax error. This is important to note. Compilation with logic error does not generate any syntax error or warning message. But when the program is run, it produces the wrong results. So, to summarize this here, when you are, I just showed you guys a syntax error in that if I delete the brackets, if I spell a word wrong, like for instance, if I take out the R from right line and I put white line and I unknown identifier, that is called a syntax error. I didn't type the word correctly. So I get an error message. So you get error messages for syntax errors, but a logic error, you will not get an error message because you typed the statement correctly. You follow the rule when it comes to typing out the statement, in that you type the statement correctly, as I said. But what you didn't do correctly is that you didn't design the formula correctly. You didn't put the right operator. You didn't put the correct loop. So basically, like in this example here, you were supposed to use less than, but you don't know your less than from your more than, and you're going to type more than. That is an example of a logic error. It basically, the design is correct because age more than 42, that's correct. But you wanted less than. So it's going to give you the more than result. But that's not the correct result that you want. So that is what is called a logic error, in that it gave you the wrong calculation. But it's not going to tell you something is wrong because you designed everything correctly. You typed everything correctly. So what happens here, this is the most difficult error to locate, because to figure out this error, you basically have to go through your entire program to try to figure out what you did not type as you're supposed to type. Not incorrectly, because you followed the rule, but what formula did you type wrong? What operator you didn't put in correctly? What loop you used incorrectly? So it's basically you having to go through the entire program to figure it out. You do not get an error message because you usually follow all the rules correctly. So when you get a logic error, all you see is a wrong result. That's all you're going to basically see, the wrong results, because you type something, you type your formula wrong, something of the sort. So, example of logic error, this segment of code will output a page when x is less than 10. Now, this is an example of what may have happened to some of you. So if x is less than 10, then print a page. So the word a page will appear on the screen. However, the programmer intended the statement to be if x is greater than 10, then the word, the phrase a page will appear. So having that wrong symbol is an example of a logic error. However, the error of putting the wrong symbol in the code means the output will be printed when it is less, and so on. So, are we clear on the two types of error? Any questions from anyone? Keela, you clear? So what is debugging? Debugging is the process of finding error. So this is the technical term for finding errors in your program. It's called debugging. The process of finding errors in the source code, understanding why they occur, and correcting them. Errors are often found through error messages generated by the program or the operating system, or because the program does not behave as expected. So the error message is usually what you see at the bottom here, or you might see a pop-up message or something. Those are called error messages. Executing the program. Whenever you hear the word execute, think of the word run. That's basically you running the program, executing or running the program. If you have translated your program to object code without error, you can now execute it and see the result. The final two terms commonly used in program execution are program loading. What's program loading? Copying a program from hard disk to the main memory in order to put the program in a ready-to-run state. Now, this is third form work, in that you have your motherboard. This is your motherboard that's inside of your computer, and you have a CPU. The CPU is what processes all of your data. You have your RAM or your memory, and you have your hard drive at the bottom here that has your program on it. This is your program that you just compiled. So when we say you are loading a program, what that basically means is that you have the program on your hard drive here, and that program has to be now stored inside of your RAM, inside of your memory. And the CPU now is going to look at that RAM to find that instruction. It doesn't look at your hard drive. It does not do that. It looks at the memory. So this program has to be loaded into RAM for the CPU to see it and then carry out that program instruction. So that's what's called loading, program loading. Linking, combining various pieces of code and data together to form a single executable object code that can be loaded into memory. Linking can be done at compile time, at load time, also at run time. So basically combining various pieces of code together to have one large program you can see. Now, once your program compiles, you may either see your results or you may see another type of error. So, as I said, when you are running the program, that is when you're going to see runtime error. Runtime errors occur as the program compiles or runs. These errors are usually due to unexpected, I don't know why they have compiled here. Supposed to be more so when it's running. That's when you're going to get the runtime error. Let me see something. Is a syntax error a runtime error? Yeah, it's supposed to be only when it's running, not really compiling. Anyway. So these errors are usually due to unexpected events, such as divide by zero, lack of memory for the computer to manipulate the data. So these are the two reasons. Well, there's more reasons, but these are just two examples as to what leads to a runtime error. So if you try to divide something by zero Like 9 divided by 0 cannot divide by 0. You guys ever try this? So it's going to give you an error that is basically you cannot do that division. Anytime you try that, cannot divide by 0. It's not going to work. So if you do that in a program, let me see what's actually going to happen. Where can I put this in this program? Let me fix that. Compile. All right. So I'm going to put it early up in the program. Begin. So I need to create a variable test is equal to real. Technically I don't need to do that, but real is going to be equal to colon equal. Yeah, colon equal 5 divided by 0 dot what did I type in real? It's supposed to be test divide by 0 error. So it's already telling me from here that I can't divide by 0. But like in this case here, I'm typing it in and I'm gonna get an error. But like if the program was running, like if the variables were changing and like I want to test it to see what's gonna happen. How can I do that? Well, that's gonna take a while, so let me not do that. Yeah, and if the system runs out of memory, has a lack of memory, you're gonna get a runtime error. So remember your RAM has a certain amount of storage. So when you check Task Manager, you would see how much of your RAM you're using. So the memory tab under performance, you can see here I have a total of 11.6, 5.8 in use. And so if this memory is maxed out, then the program is going to run into a runtime error because it needs to be inside of the RAM in order for it to work. Runtime errors can be very difficult to trace as the program may produce results most of the time. So sometimes it might work, sometimes it might not work, and you might not be able to figure out what's causing the issue. So that's even more difficult to figure out than logic error. All right, any questions from anyone so far?
No, sir.
All right, so this is exactly what I wanted to create. For average equal 1 to 5 do, results equal results divided by that by average, and that's going to be the program will produce an error message or cause the computer to freeze when the value of average becomes 1. The statement will be results equal 1 divided by 1 minus 1, which is divided by 0. Let me try quickly. See what's going to happen. Program chess var average real begin for average equal 1 to 5 do results, not declare results is a real results equal. You guys can tell me if I'm writing the program wrong also. Average if I'm missing anything. What am I missing right now? Control variable type is not valid. Control variable type. Control variable type is not valid. Huh? So var begin for count average total for average integer selected. Yeah, so that was the problem. I had to use the integer there. Another identifier supposed to be s colon expected end dot compile runtime error. So notice at the bottom there, runtime error divide by 0. So the program, so notice the program compile successful. So this case here, it's not seeing me trying to divide by 0. Everything looks okay. Then is when it runs into the error. Then is when it reaches the divide by 0. All right, so if no questions, so this chapter we basically looked at what is source code, what is object code, what is high level language, what is low level language, the translators, interpreter, compiler, assembler. What else did we look at? We looked at the 3 types of error: syntax, logic, runtime error. We looked at what is debugging. Any questions on any one of them? Anyone you want me to go over again? What chapter is this? 10.3, 10.4. All right, so 10.4, testing and debugging techniques. So let's go through this one. Testing and debugging are necessary stages in the development cycle, and they are best incorporated early. Testing begins when you start to plan the program and continues until the program is completed and put into daily use. It is set to ensure that the computer application or program is complete and does what it's meant to do. Testing attempts to find problems in your code. Debugging isolates and fixes the problems. Typically, when you test and debug your program, you need to ensure that it runs without crashing. Anybody know what the word crashing means? When a program crashes, what does that mean? It stops. Good. So your program stopped working. So when a program crashes, it means that it stops. It runs without crashing or stopping, or without generating error messages that the end user may be unable to resolve. Carries out reasonable action or produces error messages for a range of scenarios. Helps the user to continue or restart the program if an unexpected user or system error occurs. Errors can occur at any stage of a software application. They may happen frequently if you make errors while using the application, for example, but they also occur as a result of problems such as power failures. So having fluctuation in your electricity can lead to software problem. So, because remember your computer works by electricity flowing to the device. So if there's a fluctuation in the electricity going to, say, the CPU or going to the RAM, then it's going to cause them to stop work for that split second. And when it does stop work for that split second, it's going to miss some sort of instruction. And when it does, that can lead to some sort of error in the program. So even a power failure can cause error when you running a program. Testing cannot prove that your program is fully correct. It can certainly find defects or bugs. So remember, the term bug is usually, it refers to something wrong with your program, some sort of defect in your program. But there is no way to be sure. Excuse me. But there is no way to be sure that there are absolutely no errors in the logic of the program. What this is basically saying, that there is no way to fully guarantee that your program is going to be perfect. There's no way to guarantee that, because there's always something that can cause an error with your program. So even though you might debug the program and you are not finding any error, somebody else might be finding an error. So there's no way to basically create a perfect program, you can see. Therefore, the earlier a defect is found, the easier it is to fix. And that's technically why, like, for instance, a game. A game is a software. A game is a program. And when a game is being developed, what the company would usually do is they would send it out to persons, invite persons to test the game, let them use the game, play the game, to see what errors they can find, what bugs they can find. Because it's only by using it can you find errors in the program. So they would be called beta testers. So they will be testing the program to see, doing everything that they can do with it to see what they can break in the program, what they can cause an error in the program, so that they can relate that now to the developer and they can try to fix it as early as possible. So testing the program involves creating a set of test cases. So like going back to the same example with the game, they might put a scenario whereby a lot of people join the game, only one person playing in the game, a lot of maybe a lot of elements appear in the game, a lot of boxes appear in the game. They put different test cases and try to see what would cause an error in the game. Running the program with each test case and then checking the performance to see if it's running as expected. So that's how they would test the program. Create different scenarios and see if the program, if the program basically meets their expectation. Any questions so far? Our test cases. So a test case documents the values that are input and compares the predicted results with the actual results when a program is executed. So like the example I gave here, they might make 10 characters appear in the game and they check it to see if it's the same when one character appears in the game, to see if the performance is the same. So when choosing test cases, you must consider a range of values. It is important to ensure that every conditional branch, loop, and statement of the program is actually tested by using a variety of tests. So what I mean by this here is we can look at our program. So like for instance, when we were creating our program, in our program, we had a lot of tests. We have a lot of cases. Like for instance, this part here. If the gross income is less than 65,000, calculate 0% tax. So one of our test data is actually supposed to be less than 65,000. And then we have another test here. If it is less than 100,000, calculate 5%. So technically another test data is supposed to be between 65,000 and 100 to test this part here. And then another test data is supposed to be over 100,000 to test this part here. So that you can test various loops, various statements, and so on. So that's how you're supposed to be testing. Give it various values so that it can test different aspects of your program to make sure everything is working. We have the term black box testing. Now this is used to check that the output of a module is expected given certain inputs. The term black box is used because the actual code is being executed is not examined. So the black box test provides no information about whether all statements or loops of the test module are actually necessary or not. Black box testing attempts to input values into the program, process the data, and just display the value. So they're just giving it certain criterias and testing it to see if it is going to work. White box testing are designed to examine the inner structure of the program and are one of the most important test methods. The test checks the accuracy of the module from input through every possible path through the test object output. So basically, black box, you're just checking to see if you're going to get a result. That's all you're checking for. So you give an input, it gets processed, and you get a result, then you can say the program is working. You're not looking to see the various testings inside of it. The white box testing now, this is where, like I was saying with this program here, you're going to give it different values to test different aspects of the processing. So that's the white box testing. You're going to test the various loops, the various paths in your program to make sure everything is working. That's the difference between white box and black box testing. You guys follow me so far? So since testing every value is impractical, you should choose a range of values to check specific error condition. You should also be aware of which test data, if any, should be expected to produce errors. So you should, like just like in your case here, you should know that like in this test here, you should know that when a person puts in gets less than 40,000, they're not supposed to get a community. So that's going to cause an error. So you should know that like if the person enters a small gross income, that's going to give them an error. And in some cases, some of you put an error message. So in those cases, you know which values are going to give you an error. So these are some situations as to what you might test for. If the string is empty, string consists solely of white space. White space is basically just spaces. So like if Like if I run the program and I just type space and I press enter, notice that it accepted it. And I press space again, enter, space again. So for the number, it won't accept it, but for the string, it will. So I'm going to try that. Space and space. Type in a number. So notice I got housing allocation, Fort Wellington, but I don't have any name here because I typed in space. String with leading and trailing white space. Some persons even try that. They try to ask me, why can't we type space into the person's name in order to separate the person's name? So you're not supposed to be doing that. You're not supposed to be typing space if it's not necessary. Certain special characters aren't accepted, so you be careful with that. Foreign characters typed on international keyboards. For numbers, no number that is leave blank if possible. 0, small and large integer, positive integer, combination of letters and numbers. These can all lead to errors basically. So you test to see if they can accept these kind of values. If you can accept a 0, a small value, a large value, and so on. So this is an example here of testing to see if the login is going to work. So consider the program that gives a user access based on the correct username and password entered into the login screen. Examples of username and passwords as test cases can include combination of values as shown below. So they're testing to see if a person would gain access if they typed in these username and passwords basically. So that's their test case scenario. So like if they type in this username and they put the password as empty, will that give them access? So they're trying all of that. When you're testing, the testing has to be planned. Basically, like how for your trace table, you have to plan what test data you're going to use. So you created a table and put in your test data. So you got to plan what data you're using for testing your program. Some sections of the program often have to be tested before their completion. This often includes testing of other subroutines with which they interact. This part here, subroutines, remember you can take a large program and break it up into parts. And those parts, we call them subroutines. So in the real world, what we do is that we test each part individually. So we would take part 1, test it to make sure it's working. Then we do part 2, test it to make sure it's working. And we continue like that. And then we put everything together. So that's how they actually create programs in the real world. The results of these tests determine the quality of the application. Although quality varies from system to system, some common attributes include reliability. This is the probability that the inputs to and use of the software will not cause it to crash for a specific time under certain condition. So, like for instance, if you type in a lot of characters into the software, like if I type in a lot of letters like this here, will it crash the program? So that deals with the reliability of the program. So it's working with those large entries. Scalability. A software system is stable or robust if an error in its operation does not result in irreversible damage to the application. Stability, not scalability, stability. So, like, if I did this here and it caused an error, um, the application should be able to run again if I restarted it, basically. So that's stability. So, error shouldn't make it stop working permanently. Maintainability. This means how easy it is to debug, modify, and exchange. So it should be easy for you to update the program, fix any errors, and so on with the program. Usability of a program. The software system should allow flexible input by the user. The results should, output should also be clear, well-structured form, easy to interpret. Error messages must be provided. All of that relates to usability. So like how we are seeing this output here, all the information is not jumbled up together. We have like a line of space here to separate the information. That's a part of the usability. How we have a line here to indicate one section from another. All of that helps with the usability of the application. Portability. This is the ease at which a software system designed for one computer system can be adopted for different systems. So portability deals with how I can create this program here, or you guys created it, and then I am able to run this program on my system. So it's not restricted to only your system. So that's basically how we test and debug a program. Any questions from anyone? All right, the last chapter, program documentation. So documentation is an important part of the software design process. Several types are produced during the process. Documenting programming code. Documenting your code means typing short, that's supposed to be phrases or comments describing what your code is doing. So, like, I'm not seeing any. So, like in this case here, so this is documentation here. We're seeing that store the health surcharge in the variable health surcharge. So this is in the wrong location. Store the gross income in the variable gross income. So it's telling you what is happening there. Comments placed alongside your programming code are useful if the program needs to be debugged or updated. If you write your code for SBA and then review it a month later, you may spend some time trying to remember what sections we're supposed to achieve. Comments therefore help you and others to understand the purpose of your code, especially since your teacher or moderator will be reviewing it. So like how CXC has to mark your SBA, your program, commenting on it will help them to understand what is supposed to, how certain parts are supposed to work. Many students write their comments after the program is finished and working. If you leave the comments for later, you may not remember why you used a certain method, used different variables, or used another set of code that doesn't resemble the requirement. So basically, as you're working on the program, you're supposed to be commenting on the program to explain how certain things work, why you type that, and so on. Then you may resort to typing in comments that are similar to the code. This is not a good method. So comments in programming code should include the following. So you should have an overview of the entire program. What is it basically doing? The name of the author of the program, contact information in case anything goes wrong with it. They can contact the developer. The date that you would have created that program, when you would have modified it, reviewed it, and so on. If you have finally found a good solution to the part of the code that did not work, you should document what you did and include any comments that would help to explain the section of the code. So basically explaining how certain parts of the program work. Adding comments to your programming code may seem like a tedious process. However, if you add them while writing your code, you may find that explaining the section help you understand more about programming. So in Pascal, remember in Pascal we use the curly brackets to indicate a comment. Let's see. I'm assuming that in BASIC, REM is used to indicate a comment. And in Visual Basic, the single quote is indicating a comment there also. So user documentation. User documentation is concerned with what the program does and how the end user makes the program do what it's supposed to do. It is usually the first contact they have with the system. It may give details of the input, how to format output, use the printer files and so on, how to access features of the program, how to interpret any system messages. So it's kind of like a manual telling you how to use the system, how the software is going to work, and so on. User documentation should be structured in such a way that it is not necessary to read it all before starting to use the application. It is usually integrated as part of the online help with lots of blogs and online chat rooms to share information on how to troubleshoot and use the system more efficiently. 5 common components of user documentation. A system overview, which explains what the system can do and what it cannot do. So what the program can do and what it cannot do. How to install the software, how to install the system. How to configure the hardware, what settings you gotta set, what you gotta do in the system. The document suggests how to recover from errors, basic problems when things go wrong. Those are usually in the documentation. An introductory manual, which explains in simple terms how to get started with the system. So basically how to use the software. It gives you a step-by-step guide. You get a reference manual, which describes in detail all the system facilities available to the user and how these facilities can be used. This manual assumes that the reader is familiar with the system and understands its concepts and terminology. An optional system administrator guide, which explains how to react to situations which arise while the system is in use. It also carries out system housekeeping tasks such as making a system backup and so on. Yeah, so documentation is basically about how the system works, what the code is doing, how to use the system, how to use the software, how to set it up, how to install it, how to get it to work on the computer, what to do when it runs into error, a syntax error, a logic error, runtime error, whatever the case may be. Alright, so that brings us to the end of program implementation. We're finished with all of the chapter 10s. Next week, let's see. We might run through these chapters next week. And then we're going to start working past papers from there. Yeah, because it's just a few short chapters. Yeah. All right, any questions before we close? No questions? If no questions, that will be it for tonight. Enjoy the rest of your night.